Good morning, ladies and gentlemen. Today we're going to look at spherical geometry and how it can be applied to the Earth. Alright, welcome to the picture of our Earth for the topic. For the purpose of this topic, we're going to pretend the Earth is a perfect sphere of radius 6,400 kilometers. A few things to note, it's not actually. It looks like a football that's been stepped on the North Pole, so the equator bulges out slightly. The bit furthest from the center of the Earth is not actually the peak of Mount Everest. Interestingly enough, it's the peak of a volcano in Ecuador. The radius obviously changes. It's less at the North Pole, more at the equator, but we tend to average it out and further, and for our purposes, the radius of this sphere is 6,400 kilometers. Now, on a graph, we use a grid system with xy coordinates on the Cartesian plane. However, here, we use latitude and longitude, and the purpose of this video here is to explain the difference between them and how we use them to locate cities, towns, etc. on a map. You'll all have seen them before. They probably come up in your phone or Google Images or Google somewhere if you look for a location of something. Alright, meridians of longitude. Meridians are the great circles that go down, and they are the red lines. Pause. So they're these red lines that drop down here, whereas the parallels of latitude are the small circles parallel to the equator. Think parallels of latitude, parallel to the equator. How you remember these is up to you. I tend to think the meridians of longitude have a long way down to go. Kind of a stretch, I know, but it's another way simply to have this diagram in your book, coloured and highlighted so you understand which one's which. Alright. Some other terminology. When we talk about a great circle is one with the same radius as the sphere. So the equator here is an example of a great circle. You'd form another great circle if you went from the North Pole down anywhere through to the South Pole and back up again. That would have the same radius as the original sphere and therefore is a great circle. However, if we cut a line going through, say, England at the top or Tasmania way down here, they'd be smaller than the actual radius of the sphere and therefore are called small circles. Alright, mapping the world. Mapping the world starts with using longitude, which is how many across, latitude, how many up. So the red and blue, longitude is how many red ones we go around, latitude, which blue level we are up. Alright, so the 0 point, if you want to think of it as a 0 point, is somewhere in or around Africa there. And there's where we base ourselves off, whether we want to go north or south from there, east or west from there. Very simply, if we're looking at latitude, so these parallel circles parallel to the equator, we can see that the equator has a latitude of 0. It's neither up nor down. We have a latitude that's south. The northern hemisphere has a latitude that's north. Easy enough. Or if we cut the world in half, we can see that we might be down here somewhere, south, north. I'm giving you lots of diagrams. One will just click with you, I'm hoping. If not, we'll go through it again in class. The North Pole has a latitude of 90 degrees north, South Pole 90 degrees south. And you would state them like this: 60 degrees north, 60 degrees south. Alright, meridian. Now, it made sense here to have our 0 line at the equator. That's fine. The question is, what if we're heading around the world? Where does it make sense to have the 0 line? Excuse me. Turns out, well, England pretty much conquered the world at some point. So they set the 0 line straight through Greenwich, which is a town basically in London, England, suburb in London. This is an actual picture of the 0 line. Everything east of that is up to 180 degrees east, and everything this way is up to 180 degrees west, making one big circle. So here, there's the 0 line. We can imagine our 0 point here being somewhere in Africa. That's the middle of England, and then that's east and west. So here again, I like this diagram. That's the prime meridian at 0, 30 degrees east, 60 degrees, 90, etc. So how do we place ourselves in this great big mess? Well, this is Hamilton's coordinates. 37.7 south, 142 east. So what that's saying is from here, we are 37 degrees south, so down here, then 142 east. That's 90 east, 142 east is round there, the downside of the world. down under. Or if you think about it this way, that's the equator. Sorry, this is the equator. That's the prime meridian through England. This is our 0 point. We are heading 37 degrees south, down here, 142 east, around the corner to where we are. All right. What about New York? New York we can place similarly on a map, 40 degrees north. There. Then 74 degrees west, round this way here. Other side of the Atlantic to England. All right. So this is how we place everything on a map. Some amount north or south, some amount east or west. Interesting. Alright, I realized there was no actual maths there, a lot of terminology, and that is the end of that video. Just terminology on how to place things on maps. Thank you very much.